Hello student, how are you today? I'm very fine. Thanks the one. Okay, today we are going to see grade 9 maths lesson 2. Before we are going to proceed this lesson, I want to ask you some questions. How was the classwork, the last time classwork? I think it is quite easy, right? Alright. Okay, let's come to just simply to the today's lessons. The today's lessons is about trigonometric ratio to solve right angle triangle. The basic objective or the thing that you should make sure at the end of this lesson are 1. Solve problem related to right angle triangle, and the second one, find the exact values of special angles. When we are going to say trigonometric ratios, as you have learned it in the previous grade, that's grade 8, trigonometric ratios are ratios that are expressed as a form of, it is the relationship between angles and sides, which is you already learned it in the previous grade. It is like sine, cosine, and tan. Before we are going to discuss about this trigonometric ratio, we are going to see some abbreviation that which we are going to use over here. The following abbreviation are commonly used. Ad stands for adjacent side, and hyp stands for hypotenuse, and op stands for opposite sides. So sine A is defined as the opposite sides of that of the angle A divided by the hypotenuse, and cos is the same as cos equals to is adjacent over hypotenuse, and tan is equals to opposite over adjacent. If you are going to take right angle ABC, and if you are asked to find sine A is equals to the opposite sides to that of angle A divided by the hypotenuse of the right angle triangle, which is the same as with the opposite sides of angle A is BC, and the hypotenuse is BA. So sine A is equals to BC over AB. BC over AB. And cos A is equals to the adjacent sides of that of angle A divided by the hypotenuse. The adjacent side for angle A is AC, and the hypotenuse is AB. So cos A is equals to AC over AB. Tan A is equals to the opposite sides of angle A over the adjacent sides of angle A. The opposite sides of angle A is BC, and the adjacent sides of angle A is AC. So tan A is equals to BC over AC. From the above point, we are expected to do example 1. Example 1, in the following right triangle, find the values of sine, cosine, tangents of the acute angles. So in order to do these questions, first we should observe carefully the right angle triangle. So when we are going to see the right angle triangle, AB is 5 units, and BC is 3 units, and S is 4 units. So in order to find the sine, cosine, and tangent values of this right angle triangle, we have two angles that which will determine the sine and the cosine and the tangent values of the angles. The angles that which we are going to use to find the sine and cosine and tangent values are angle A and angle B. So in order to find sine A, as we have stated earlier, sine A is the opposite sides of two radians of the angle A divided by the hypotenuse. The opposite side to the angle A is BC, which is equal to 3, and the hypotenuse is AB, which is equal to 5. So sine A is equal to 3 over 5. And again, cos A is equal to adjacent sides of angle A divided by the hypotenuse sides of angle A. So adjacent divided by the hypotenuse, the adjacent sides of angle A is 4 unit, and the hypotenuse sides of angle A is 5. So cos A is equal to 4 over 5. Tan A is equal to opposite over adjacent. The opposite sides of angle A is 3, and the adjacent sides of angle A is 4. So tan A is equal to 3 over 4. Similarly, sin B is equal to the opposite sides of angle B divided by the hypotenuse. The opposite sides of angle B is AC, which is equal to 4, and the hypotenuse is 5. So sin B is equal to 4 over 5. And cos B is equal to the adjacent sides of angle B divided by the hypotenuse. The adjacent sides of angle B is 3 BC, which is equal to 3, and the hypotenuse is 5. So cos B is equal to 3 over 5. The last one, but it does not mean the least, tan B is equal to opposite over adjacent, which is equal to the opposite sides of angle B divided by the hypotenuse. The opposite side is divided by, the adjacent. The opposite side is AC, it is 4 unit, and the adjacent side is 3. So tan B is equal to 4 over 3. So sine, cosine, tangents of the angles 30, 45 and 60 degree are summarized in the following table. We are going to see the exact values of special angles. Sine 30 degrees equals to 1 over 2. Sine 45 degrees equals to square root of 2 over 2. And sine 60 degrees equals to square root of 3 over 2. Cos 30 degrees equals square root of 3 over 2. Cos 45 is equals to square root of 2 over 2. And cos 60 degrees equals 1 over 2. Tan 30 degrees equals to square root of 3 over 3. Tan 45 degrees equals to 1. Tan 60 degrees equals square root of 3. In order to determine, we can take tan A is equal to sine A over cos A. If you are going to, let's say for example, if you are asked to find tan 30 degree, we will divide sine A, which is 1 over 2, and cos A is square root of 3 over 2. If you divide 1 over 2 over square root of 3 over 2, it will give us square root of 3 over 3. The angles 30 degree, 45 degree and 60 degree are called special angles because they have the exact trigonometric ratios. Example 2. A ladder 6 meter long leans against a wall and makes an angle of 60 degree with the ground. Find the height of the wall. How far from the wall is the foot of the ladder? Here we are asked to find the height of the wall and the length between the foot of the ladder to the building. So, in order to solve this kinds of application problem, we use the one that we discussed earlier. Consider triangle ABC that's displayed on the figure 5.76. Assume this is triangle ABC. Measurement angle is equals to 60 degree and measurement angle C is equals to 90 degree because it forms right angle with the ground. Measurement angle B is equals to 30 degree and AB, the length of the ladder, that means 6 meter. We wanted to find BC and AC, which is the heights of the building and the distance between the foot of the ladder and the building. So to find BC, or the height of the building, we use sine 60 degrees equals to, it is opposite over hypotenuse, so the opposite side to that of 60 degrees it is BC, and the hypotenuse is 6. So sine 60 is, as you have stated earlier on the table, it is equals to with square root of 3 over 2. Square root of 3 over 2 is equals to BC over 6. If you are going to crisscross this one and simplify it, therefore BC is equals to 3 square root of 3 meter, which is the height of the wall. To find the distance between the foot of the ladder and the wall, we use cos 60 degrees equals to AC over AB. Cos 60 degrees equals to 1 over 2 from the above table, and AB is 6, so 1 over 2 is equals to AC over 6. If you are going to bring 6 to the left hand side of the equations, 6 times 1 over 2 becomes 3. So AC, or the distance between the foot of the ladder and the wall, will be 3 meter. How was it? Is it difficult? I don't think so. I know you are smart, you can do it. Alright, in the above example, if the angle that the ladder made with the ground were 50 degree, how would you solve the problem? Can we use the special angles? Do you think 50 degrees is special angles? To solve this problem, you would need trigonometric tables, which give you the values of sine 50 degree and cos 50 degree. Okay, here we are asked to do without using table. Here we have the classwork. Without using table, find the value for each of the following. Answer may be left in radian form. You can just leave the answer in radian form. Not even worrying about just displaying the answer in degrees or expressing them in degrees. You are expected only to do the first questions. So question number 2 and question number 3, you are expected to do after the end of lesson 3, not at this time. How was the class? Do you really understand it? I hope so. So for the next time, you are expected to do this classwork, and I will give you the correction after you are going to finish lesson 3's classwork. Don't forget, practice, practice, practice. Practice make perfect. Have a nice time. Bye bye.